Deep learning and machine learning. So we are taking the interview question and answer. So this is useful for interview, quiz, examination. So we are talking about artificial intelligence. These are basic interview questions. What is the difference between machine learning and deep learning? So in both of them, you see, learning is already there. So they come under the umbrella set or the bigger set, which is the artificial intelligence, AI. And inside this, we have machine learning. So this is supervised, unsupervised, and also the reinforcement learning. Inside this, we have deep learning. This is a subset of machine learning, and this is based on artificial neural network. So whenever we talk about deep learning, we are trying to mimic the human brain in terms of structure called neurons, and therefore forming the artificial neural network. So in machine learning, we use statistics and algorithms to train machine and data, thereby helping them improve with the experience. So deep learning, whenever deep learning comes, you have to think about the neural networks, your brain. So you are trying to make a machine like yourself, like intelligent people. So first artificial intelligence, then machine learning, then deep learning. What is perceptron? Perceptron. So perceptron is a single neuron with a single output. So perceptron was given by a famous scientist first. He actually showed that how a neuron can be shown, projected and computed. So what is going on here is a neuron, single neuron is getting some input, and these inputs, the lines which you see, if you see the inputs are say x1, the weight is w1. Weights are simply the importance given to that x1 or x2. So we multiply this x1 and w1, x2 and w2 till xn wn, and then you send it to the neuron. Then you add a bias. Bias is simply a value, just we don't want it to go always from the origin. So we add them, and then finally we pass it through the activation function. So this perceptron is mainly used to perform binary classification, where it sees an input, compute functions based on the weights of the input, and outputs the required transformation. So this is actually neuron in human brain. How is deep learning better than machine learning? So machine learning, the deep learning is the subset of machine learning, which in turn is the subset of artificial intelligence. Machine learning can be of three types: supervised, unsupervised, and reinforcement learning. Inside this, we have deep learning. So here we are talking about it is having an upper hand on the machine learning, because we are talking about large number of dimensions. So we want to have a machine which is based on general AI or say strong AI. We haven't achieved it, but we want it. So with data which is of large size, deep learning can easily work with it, as it is built to handle this humongous amount of data, huge data, big data, all kinds of multi-dimensional data. So wherever we talk about forward propagation, backward propagation, we want the machine to learn how to recognize, how to distinguish. So if you see here also the pattern, how this neural network and the traditional machine algorithm, on the basis of accuracy and data, they vary. So with more data, the things changes. That is why there is an advent of and the thrust on the deep learning, because of the humongous data which is there on the platforms, maybe social, otherwise. What are some of the most used applications of deep learning? Most used. So whenever deep learning comes, you have to just think about the neural networks. So there are a variety of fields today. So we have the applications of machine learning also, just for your understanding. and the applications for deep learning also. So in order, if this question comes for machine learning, you can give that this image what is shown. But for deep learning, sentiment analysis, computer vision, automatic text generation, the object detection to detect very precisely natural language processing NLP. If in Gmail, if you write as soon as, or even if you write as soon as possible, will come automatically. That is natural language processing. Image recognition also. What is the meaning of overfitting? When you try to overfit the data, that is called overfitting. Okay. Now let us understand with the diagrams. Overfitting. Along with this, we have underfitting also. So overfitting is a very common issue when we are working with deep learning. So what is the scenario here? The deep learning algorithm vigorously hunts through the data to obtain some valid information. It just goes and tries to find out some valid information. So this makes the deep learning model pick up noise. For example, you have thought you will get 80 in an exam. You predicted that and you got 90. So you overfitted and you got 70, that is underfitted. So now deep learning model is, because of it is vigorously hunting, it is picking up the noise rather than the useful data. Okay, causing very high variance, because if you are taking noise and the actual data, there will be high variance between these two and the bias will be less. So actual data, noise, and it starts picking up the noise because it's working with that intent to work hard to get the actual result. So the accuracy which wanted we don't get. So the model becomes inaccurate and there are undesirable effect which is seen. So if you see, this is the underfitting. Too simple to explain the variance here. And here you see overfitting. It's being overfitted here. Force fitting, too good to be true. You cannot have like this, or even if you have this, then the noise will be more than it is being picked up more. What are activation functions? So in one line, this activates the neuron. In one line, activate functions activate neurons. So activation functions, these are different kind of functions I wanted to show you. These are entities in deep learning that are used to translate the input into usable output parameter. That is, this function decides neuron will get deactivated or activated. Okay. So what is done here is, let me just give you a brief here. I have to take you to the background also. This is your neuron. Now you have given some input. Say this neuron is in your input layer. So you have given some weights also. Weights are just the importance given to the different inputs. Now when you pass it, x1 into w1, x2 into w2, these are multiplied and added, and a bias is added. Now these values for multiple neurons, this is not one neuron, there will be multiple neurons. x1 w1 plus x2 w2 plus xn wn plus a bias for a single neuron, there will be some value. And this value, the bias is just, we don't want things to go very precise, or you can say very unrealistic. We just want this c to be added so that we don't want every time the origin to be taken. Realistically, we add bias. So, but this is not one neuron. There are multiple neurons here. For example, you get some value, 2 lakh. This may be ambiguous, 2 lakh or minus 2 at 2 lakh. Maybe, you don't know. So we use activation function. Whatever value is coming, we will always fit them into, say, a range, minus 1 to 1, 0 to 1. Now all the values which the different neurons are producing, we need a proper boundary. For example, the sigmoid function gives you the value always, whatever you put it inside, it will always give you from 0 to 1. So all the values which are coming outside will be easily to handle. Why is Fourier transform used in deep learning? So this Fourier transform is all about converting, changing from time domain or spatial domain to the frequency domain. You get frequencies here. The different kind of Fourier transform. You have the fast Fourier transform like this. So this Fourier transform is an effective package used for analyzing and managing large amounts of data present in a database. Large amounts of data. It can take in real-time array data and process it quite quickly. So this ensures that high efficiency is maintained and also make the model more open to the processing of various different variety of signals. So as I'm telling, if you apply FFT, fast Fourier transform, it will be more faster. So it gives you efficiency and it is able to handle or manage large amounts of data as well present in the database. Fourier transform, that is why it is used in deep learning. What are the steps involved in training a perceptron in deep learning? Perceptron is the basic part of any neural network because perceptron is all about one neuron with multiple inputs and single output. So if you take any neuron, there will be a series of steps. I have highlighted these steps. You can go through, but let me show you how actually things are done. Here we want a cat or dog to be recognized. So how to train a neuron, that is a perceptron? So say if you have given some input cannot be changed. It will always be there. So we have weights for each input, how much importance you are giving to certain inputs. You have weights for every input. You add bias when you multiply x with w, x1 w1 plus x2 w2 plus xn w1 plus the bias, and then pass it through activation function and some value will come. So now when you get the actual value, which may be different from the predicted value, the true value and predicted value may have difference, then you send that value back that okay, you need to change the weights. So this is done again and again. This is how you train a perceptron. What is the use of loss function? Loss function. So what is loss here? People generally confuse this with the mean squared error. So let me show you what exactly loss is. So you can just read the text. I'm going to tell you the whole process. So in every neuron, this is going to be done. So you have an output. Say the output is coming as 5. You wanted 3. 3 is the actual, 5 is the predicted. So what is the difference? 2. Now this you have to do for every neuron. For example, some neuron is giving you say 2.5. So what is the difference? You wanted 5, 2.5 has come. So 2.5 is the difference. So basically there is an error of 2 and 2.5. How to combine them? We just take the true value and the predicted value. We subtract them and we square them because we don't want the negative values. And after that you can square root also. Square and then take the square root. That is mean square or mean square root error. And you have to divide it by n also because there are number of samples, number of data which you have inputted. Okay. So this shows that what is the error in your prediction of the neural network. But now you need to how to get this mean square error as 0. What you will do? x1, x2 you cannot change. You can only change the weights or the biases. So now you have to change the weights. So you have to write a loss function. That is, you have weights, x input value you cannot change. That is already there. Weights you have by yourself chosen. The biases you have chosen. So W1 to W1 and B1 to Bn, these will all are the variables that you have to deal with in a loss function. So this is called a loss function. Then if you want to, because we use the partial derivative, because one time you are dealing with W1, one time you are dealing with W2. So you want one to keep constant, one to derivative and others to keep constant. That is why you take derivative. And finally a value comes after applying the chain rule, and that value is the actual value you need to change or given to weight that okay, you need to be changed by this number, and then the final until your MSE becomes 0. What are some of the deep learning frameworks or tools that you have used? This is a very common question in interview. Always asked because by this the interviewer will know that whether you have worked on this or not. So you need to know which is coming from Google, what is coming from Amazon, from Facebook, from Microsoft. For example, PyTorch is coming from Facebook, the TensorFlow is from Google, the CNTK from Microsoft, MXNet from Amazon. So TensorFlow, Keras, PyTorch, Caffe2, CNTK, MXNet, Theano. These are all the deep learning framework which are available, being used by different, like for example, Keras is just a wrapper. TensorFlow is a low-level kind of, say, library. Similarly with PyTorch. What is the use of Swish function? Swish. Why we are talking about Swish function? Because it has come from Google. And we know whatever Google has done, it's always successful. You talk about Google Pay, you could talk about YouTube, anything Google has presented, always successful. So previously, people were using Sigmoid, then they started using Grelu. Then this orange line is actually depicting the sys function. So it is now a very popular activation function, and this ReLU function will be 0 till origin from left, and it goes like this, a straight line, all right. And this is the sigmoid kind of curve, S curve. But when we talk about this Swish, Google is claiming that it is outperforming all the other activation function in terms of computational efficiency. What are autoencoders? Autoencoders. Actually, it's not only encoder, it is combination of encoder and decoder. So there are multiple purposes of this autoencoder in artificial neural network. Or these are basically ANNs which learn in unsupervised manner. So autoencoders, artificial neural network, unsupervised learning. These networks have the ability to automatically learn by mapping the input to the corresponding output. That is, the image if you give, it should come the same way. Then input should be equal to output. So it has a taper till it goes to a certain computation state which we want. Then again it elongates till we get the final same number of neurons as the previous one. So for outlier detection, it is very good autoencoders. For the compression, it is very good, and for reduction of dimensionality, it is there. So this shape, like as I said, this is the shape which you must remember of autoencoders. The first part is encoder, second is decoder. So encoder, this is used to fit the input into an internal computation state. Here, decoder is used to convert the computational state back into the output. This is the autoencoders. This question will definitely come. What are the steps to be followed to use the gradient descent algorithm? Now, first thing is the gradient descent algorithm is for optimization. Let me tell you again, we have discussed it, but we have to discuss it again. We have x1, we have xn, different inputs. So let us just assume x1 is there. It is having weight. The output will come, mean square error you will find. You will see the difference. What is the difference? And then you will try to make a loss function. Then you will take, because I'm just assuming x1 with weight 1. There are multiple xn. So we'll take the partial derivative. We just want to change the weight 1. Then we wanted to change the weight 2. So we'll take the partial derivative. And this is to be done with all the weights and all the biases. So just assume that we are doing it for weight 1. And when we do this, we get a value. And that value has to be deducted from the weight, actual weight. And that deduction will always be done. So until the proper weight for the actual output, good output, is achieved. So this W1 is W1 minus eta delta L by delta W. For example, 0.5 is coming, we want to get a boy or a girl. Boy is 1, girl is 0. But the neural network is giving 0.5. So delta L by delta W1 is 0.24. So you have to subtract this 0.24 into some eta with the weight, because you're not getting the good result. So this W implies W, or W is equal to W1 is equal to W1 minus eta delta L by delta W1 is your gradient descent. Here eta is the learning rate, it is between 0.0 to 0.1. So you are actually changing the weight because you want optimization. And there is a concept of local minima and local maxima. You don't want a local minima. This gradient descent is only about finding the slope and taking you to the exact point where it should. Differentiate between a single layer perceptron and a multi-layer perceptron. In single word or single sentence, single layer perceptron is one layer of hidden, and multi-layer perceptron multiple hidden layers. So single layer perceptron cannot classify a non-linear data points. Multi-layer perceptron can classify non-linear data. You have multiple hidden layers. Single layer perceptron takes in a limited amount of parameters. Multiple layer perceptron withstands a lot of parameters. Single layer perceptron less efficient with large data. Multi-layers of perceptron highly efficient with large data. Let me tell you again. You have output layer, one hidden layer, input layer, and the one output layer and hidden layer. This is your single layer perceptron. We have input, output and multiple hidden layers. That is the multi-layer perceptron. What is data normalization in deep learning? The data normalization is a data pre-processing step. You see, these are two data. One is not normalized, one is normalized. I'll give you an example. You have a sound, say audio file, and this is how it looks. This is not normalized. If you want to normalize, you just put it between some boundary. So you have made it normalized because we want every data to be between certain range. Okay. So data normalization is a pre-processing step that is used to refeed the data into a specific range. So this ensures that the network can learn effectively as it has better convergence when performing the back propagation. Because you cannot have somewhere very high, somewhere very less. You have to put it inside certain range. So if you see here 58 for 51, 51, 41. So range is from 41 to 58. Now you have 43 to 54. So this is how the data should be in a normalized form. What is forward propagation? Forward propagation. Forward means going ahead. Propagation means streaming or sending. So forward propagation is the scenario when inputs are passed to the hidden layers with weights. So you have weights here. These are different, means output layer, input layer, and inside we have hidden layer. So in every single hidden layer, the output of the activation function is calculated until the next layer can be processed. Okay, it is called the forward propagation, as the process is beginning from the input layer and it moves on and on till it reaches the final output layer. This is forward propagation. The reverse of this is back propagation. Backward propagation is for just the balancing or reassigning the weights and biases. So as I said, we find out the output and then we find out the mean square error from the actual value, that is true value and predicted value. Then you find out make a loss function, then you try to change the weight 1 so that you get a good result, and you do it for every weight. So then we find out the gradient descent, that is for optimization. So now you change the weight, that is weight is reassigned as W1 minus eta, delta L by delta W1. This eta is the learning rate. So weight you have changed. Now when the weight needs to be changed, you have to tell neuron unweight. So you have to go back, and this is done through the chain rule in mathematics or mathematic computation. So starting from the output layer, going back to the input layer, backward propagating, this is called the backward propagation. What are hyperparameters in deep learning? So I told you about gradient descent. So the eta is there. What is eta? Eta is a learning rate. So it is a hyperparameter. So hyperparameters are variable used to determine the structure of a neural network. They are also used to understand the parameters, such as I given you the example of learning rate. For example, number of hidden layers are also there. Number of epochs are also there. Momentum is also there. So for example, eta, These all are very important as far as the structure of a neural network is concerned. I'm not going into the model design and model parameters, but hyperparameters are these. There is a question coming, so I'll discuss more about this in the next question. So hyperparameters, variable used to determine the structure of a neural network. How can hyperparameters be trained in neural networks? So I hope you got the idea of the previous question. Let us start with the batch size, epochs, momentum, learning rate. So hyperparameters can be trained. We have 4 parameters here. So batch size, then because you need to change the values. Batch size, this is denoting the size of the input chunk. For example, you have x1 to xn. This can be 100, this can be millions. This can, you don't have a limit for the number. So you want to send it in a batch. So batch sizes can be varied and cut into sub batches based on the requirement. Epochs denotes the number of times, number of iterations the training set is visible to the neural network so that it can train. This is iterative. Number of epochs will vary based on the data. So let us talk about learning rate. Learning rate is used as a parameter to denote the time required for the network to update the parameters and learn. It is between 0 to 1. You can have any value. We have to be very specific with the chosen value. Momentum is used to understand the next consecutive steps that occur with the current state being executed at hand. Because sometimes there is a oscillation problem. So in order to avoid this oscillation while training, we need a proper momentum value to be set. Okay, these are the basic questions we have discussed. We'll be talking about the intermediate and advanced. Till then, thank you so much. Take care of yourself.